So good afternoon. Welcome to our presentation which will detail New Zealand's eruptive heart. So as you can see, we're talking about volcanoes here. So I'm briefly going to introduce New Zealand's volcanic origin, then move on to the hazard zone across New Zealand's North Island, and you have to know that New Zealand has North Island, South Island, and of course Geologist Island at the bottom. Then I'll progress on to the Auckland volcanic field, and then discuss 3 volcanoes in the Taupo volcanic zone, and then finally summarize at the end. So New Zealand formed as a result of subduction. The Pacific plate formed beneath the Australian plate over time due to the fact that the oceanic crust was more dense than the continental crust above it. And as a result, in the subduction zone, you have volcanoes which form as a result of plumes of lava, or magma, beneath the surface, flowing up to the top and then spewing out magma, lava, ash deposits and the like. So across New Zealand, the hazard zones might primarily lie across Auckland and Bay of Islands to the north, and Whangarei, and in addition the Taupo volcanic zone, which is one of the key areas in the heart of the country. If you imagine the human body, your heart pumps blood. Well, New Zealand's core magma chamber primarily lies beneath a lot of these volcanoes, as you see on the screen to the left, which I'll go on to discuss: White Highland, Tongariro, and in fact Lake Taupo. So this here is a map of the Auckland volcanic field. Now this is my personal copy of the map produced by the European named Hochstetter, who ventured off to New Zealand in 1859 and sort of mapped out all the volcanoes across Auckland. And as you can see on the diagram here, this is the largest volcano offshore, off the coast of mainland Auckland. This sort of centre here in the dark red is the area where the volcano erupted first, the vent if you like, and then around in the sort of pinkish colour is the extent of the volcano. And you'll appreciate this diagram is not so up to date. So many years later, in the 21st century, the Institute of Geological Nuclear Sciences in New Zealand, similar to the BGS in the UK, produced this diagram, which is a bit clearer than before. So, as you can see in the top right here, it's Rangitoto. This island is an example of a hotspot volcano. It formed, along with a lot of the other volcanoes in Auckland, as a result of a magma chamber 100 kilometres below the surface of Auckland. One plume of magma went off at random, but this whole city, one country really, is extremely volatile, which I'm sure you've known from the numerous earthquakes in Christchurch. You can see that around the centre of the city, there are lots of volcanoes here. There's said to be up to 50 in total. I, having grown up in New Zealand, spent my primary years in and around One Tree Hill, Three Kings, Mount Smart, Mount St John's, Mount Roskill. So I can definitely say that the ash, the pilly, tuff, which is demonstrated by the sort of pinkish locations here, are widespread, and a lot of it is intermingled. So the lava and scoria deposits across all the city in the darker red, as you can see, a lot of it's overlapping, which makes it hard to definitively map, which I'm sure Mr. Hochstetter and numerous other scientists going forward have struggled with. Now, as an example of a hotspot volcano, so you imagine Hawaii. It's not at a plate boundary, it's within a plate. So it formed as a result of pyroclastic eruptions between when the magma reached to the surface, mixed with seawater, and formed an explosion crater. Now, often this was kind of very dramatic, very explosive, and where it wasn't on seawater, where it was on land, it formed scoria cones. As you can see, all the remaining cones across the city are widely spread out. But it causes a headache when it comes to planning new suburbs, because planners aren't going to know, neither are volcanologists, to 100% accurate, where the next plume is going to dot the surface. So everywhere in yellow you can see is land that isn't affected by volcanism. But as you can imagine, it's quite dense in some parts. Now, this is kind of a comic image of myself to the left, Orangatoto to the right, which, as I explained before, the hotspot volcano, quite flat sides, relatively shallow, and quite symmetrical. Now, moving forward, this is an example of another volcano, but it's different. It's a stratovolcano, so it's a series of layers of ash and deposits and lava, all forming within the sea, just off the coast of the Bay of Plenty. And you can see the white steam cloud, which is permanently there. It's as a result of the lava and magma constantly interacting with seawater below. So this never goes away, you always see that. The yellow around the base of the island is a result of sulfur. Back into the 1970s, you used to be able to go there, but now the concentrations of sulfur dioxide, carbon dioxide, and numerous other gases are highly toxic in high concentrations. So if you are allowed there, you're only allowed there in supervision by research staff and volcanologists, etc. Tongariro, I've been moving down into sort of the heart of the country near the centre, just south of Lake Taupo. It is an example of another stratovolcano, and it's been erupting since the last 275,000 years. And its latest eruption is 1977. It's completely 100% active. Having walked between Tongariro and its volcano behind Narahoe, I know for a fact it's warm. So when you walk through the track, you can touch the side walls, which are pretty incredible, I have to say, as a geologist. And you are able to take any samples you want, which, you know, as geologists, we all like rocks. It's an example of a stratovolcano, so you can see the layers on the left, different layers of ash, lava, all accumulated over time. I know for a fact that it's next to another volcano, which is Ruapehu. So if you imagine lots of little hobbits in Lord of the Rings, this was the scene, the setting for Mordor. So it's kind of great for tourism and also, well, good for volcanologists as well. Now this Lake Taupo, you think to yourself, it's just a lake. What's wrong with the lake? It's just a, 616 square kilometre area that formed, but it harbours a secret. It formed as a result of an eruption that started in 27,000 years ago by an original volcano in its place called Aronui. Now, this increased in its volatility, explosivity, up until the 2nd century, when it blasted out all its lava, ash, debris, in terms of a rhyolitic style eruption. So very, very, very explosive. They're said to be 50 kilometers high was the eruption plume. So it's the largest caldera eruption in the last 5,000 years. It's said that in Rome and China, they had red sunsets, which were recorded in their literature. It sounds strange because people don't really hear about Lake Taupo. And I think they should, because across the country, the central part of New Zealand, deposits up to 15 to 150 meters thick in places, up to 100 to 300 kilometers away from the perimeter of Lake Taupo, which is quite incredible. It's something that, well, you mentioned maybe Mount St. Helens, Vesuvius. Yes, those eruptions spread a long way, but for something to erupt such power, to cause a hole, if you like, 616 square kilometers in size, and then naturally fill up with rainwater, hence we've got the lake today, it's incredible. As an example of a caldera volcano eruption, so once the volcano blew its top, the surrounding crater walls collapsed, and over time, rainwater was filled in, and this is the lake you see today. I've been there many times, and you see it's quite tranquil, but it's one of the most actively monitored locations in New Zealand due to its, volcanicity. And they say that the eruption interval is up every couple thousand years. So frankly, I think we're overdue. And yes, no one mentions it, but perhaps it's only the volcanic community that has a clear mindset around the past. So in summary, just like to say that Auckland Volcanic Field, as you can see, all the volcanoes are quite small in relation to what Lake Taupo was. The Lake Taupo, Tongariro, and White Highland are all examples of stratovolcanoes, and caldera volcanoes as well, with increasing seismicity and volcanicity. When the next eruption may be, you tell me, I don't know. But frankly, it's a great volcanic question which could be explained in future.